state. So this is a summary of the main activities, but there's certainly more things we can add, and we will be talking about them as we move forward. All right, so now let's talk about the two phases of CI/CD, or the two pillars, starting with what is known as continuous integration and some of the capabilities within AWS that will help us to address the actions that happen here. So continuous integration refers to the ability of taking the code from the source repository and automatically create a valid build. We can think of this process in different phases, as we can see. First, as soon as a developer adds some code to the repository, either through a branch or maybe through a pull request, we should be able to pick that source code, create a consistent build, and test it. We should automatically validate that this new code is optimal and has met all the bars that it needs to ensure that. The result in the step 3 will be this artifact that is ready to be deployed. And something very important is that we should have effective ways to provide feedback when these constraints are not met, right? So maybe using logs or notifications, but the developer should be able to see the reason and quickly iterate on a new version with fixes. In terms of tools to accomplish this purpose, we have Code Pipeline, which plays the role of orchestrating all of these steps in a single place. It allows us to design and visualize the different steps that we put together in the pipeline, and control if things pass our validations or stop the process if they fail. Initially, it will pick up the changes from the source repository, and in order to do so, it will integrate with third-party tools like GitHub, GitLab, and Bitbucket. So there's a nice combination of tools that you can use for this orchestration with Code Pipeline that will depend on your use case and the way you want to build and deploy your application. At the source code level, we can connect Code Pipeline to our GitHub or GitLab repository, as we mentioned, but we can also connect it to Docker images on ECR. So every time you tag and push your image, you can make Code Pipeline to read your code from those, right? So in the same logic, we can also use S3 files as a place to store our content, right? So in the same direction. And aside from these source configurations, we can also decide how to trigger our builds. It doesn't need to be every time we push change to our repo, which is the common approach. We can also use other options like flow watch events to trigger builds on a certain schedule or when an external event happens by using custom webhooks. We can do that as well. Finally, we have different options where we can tell Code Pipeline to deploy our solution into, and this can be standard EC2, but also more high-level services like Lambda, or also container-based like ECS, Fargate, or AppRunner. So while Code Pipeline help us to orchestrate the different steps on continuous integration, we have also Code Build as an essential tool that will help us to actually perform the tasks on every step along the way. Code Build will allow us to compile our code, run different types of tests, and also run any validation checks that we may need, maybe database schema changes and so on. And it will run in a new Docker container every time a new process starts, so it doesn't save any states or data from previous executions or tasks. The most important feature...
Sorry, about that, about Code Build. What are the advantages of using Code Build over traditional tools like Jenkins?
Right, so Code Build covers a certain part compared to Jenkins. It focuses on providing a serverless functionality to run our scripts and features, and we can customize it and just pay for the actual build time. So I guess that's the big difference and benefit about code build. While Jenkins require us to maintain that server, and but we can also take some benefits from Jenkins, like the plugins and things like that. So can be complementary tools, I will say. It doesn't mean that we need to decide between one and the other, but code build focuses on that particular part of executing scripts and processes, running tests, and we don't need to manage that server. So I guess that's the big benefit about code build. We will get to a point, but ideally the combination of using code pipeline with code build and also code deploy will benefit us with the same purpose as Jenkins does. Right?
Great.
So the most important feature, I will say again, is that code build is a fully managed service, and this means that we don't need to pay or maintain the servers while they are in idle status. We just pay for the actual build time instead of having that server just waiting for the next task. And as it can be expected, code build integrates natively with code pipeline. This means that we usually work with both services in the same console dashboard, which gives a good integration experience. And in order for us to tell code build which tasks to execute, we need to use a specific file called build spec that is written in YAML format, where we can specify the commands or scripts that we want to perform. And here there are two very simple examples of things that we can do during these tasks. On the left side, we are building a Docker image with our source code and pushing that image to ECR, where we can later pick it up and maybe deploy to Lambda or Fargate. On the right side, we have another example, even simpler than that. We just run unit tests for a Node application. So possibilities are endless on the things you can run and set up using code build, but hopefully you get the idea. Now let's talk about our second pillar, which is continuous deployment. We have now our artifact ready to be deployed because it has been tested, compiled, and has succeeded on all the checks that we have defined. So continuous deployment is about deploying these changes into production. But we can also do several stops in the middle, maybe to deploy into other environments, test, QA, UAT, where we want maybe humans to participate on the approval of those changes, so then we can move forward into production. There's another term that you'll often hear, which is continuous delivery. And while they are used as the same thing, usually continuous delivery lets the final deploy to production to be a manual action, right? So I guess there's that small difference. But continuous deployment also considers that to be an automated process. This means that we can choose between different strategies on the way we deploy into production. Common strategies are blue-green and also canary deployments. But in the same direction, we need to think about strategies for rolling back our changes automatically if things go wrong, which is perfectly normal on a release process. In terms of tools in AWS for code deployment, we have AWS Code Deploy, which essentially takes care of moving our artifacts into a running environment that can be ECS, Lambda, EC2, or even on-premises servers. It comes with a configuration of different deployments and rollback strategies that we can already use. Again, which configurations we choose will depend on the type of application and needs that we have in terms of downtime to make sure our deployments go smoothly. Code deploy is typically used together with code pipeline and code build, and these three services provide the features for the complete CI/CD lifecycle, right? So it can be, the three of them can be compared with tools like Jenkins, maybe GitHub Actions, Circle CI, but fundamentally using AWS services and ecosystem, right? And similar to what we had for code build and the build spec file, code deploy uses a file called appspec YAML, where we will define the details of our deployment. And here are two examples. On the left side, we have the configuration for a deployment into EC2, where we simply invoke a few custom scripts that are needed to set up our application, maybe change permissions, start our server, and so on. And on the right side, we have the deployment configuration for a Lambda function. We tell codedeploy to perform an update to our Lambda functions and switch versions. And we can also trigger, in this case, scripts to maybe validate our Lambdas are working as expected. So at the end, the details of these files will depend on the running configuration you have. If it's ECS, it will look a bit different and so on, right? So now in terms of deployment types that code deploy offers, we have a few options again. On the left side of the presentation, we can first group our servers into what's called a deployment group. And this means that we can support a complex deployment with different set of instances or servers that may exist in different regions or accounts, right? So we can consider them as part of the same deployment process. This usually will be just a single deployment group, but it also supports that complex type of configuration. And once we define that, we can decide how this deployment will happen. And here we mentioned the two most typical strategies. These are very simplified graphics, but one of them is blue-green deployments, where we will create a new replica of our environment, running the version, the new version, and then switch traffic between the two, usually with the help of a load balancer. And we can also use a canary deployment strategy, where we transition the traffic of users periodically, right? So we can define the speed and rules of that transition. That means that we can say, for example, I want 10% of my users to get the new version for 10 minutes, and we can monitor that, right? So the impact is less in that sense, right?
Yeah, how do you decide which one to use, blue-green or canary?
That's a good question. Typically, blue-green is associated to more monolithical applications. There are a few advantages and disadvantages of using one or the other. With blue-green, you get an all or nothing type of migration. So if you move to V2 and things doesn't work, you need to roll back everything to V1. And with canary releases, you have a bit more of control, but also the traffic control, it's more complex in that sense. You need to configure the migration type, but also rolling back the strategies tends to be more complex. Also for blue-green, you need to replicate exactly your production configuration. So you might be overspending for that setup. So again, it will depend on your use case, and they can also be used together. Maybe if you have microservices, you need to work with both in certain manner. Also for canary deployments, your impact is less. You just test your new releases to a certain amount of users, and you validate that the new change is valid, and then you decide if you want to move forward. And we will be seeing how this canary deployment works with the code deploy demo that we will be doing shortly. So while this in theory covers the concepts of continuous integration and continuous deployment, I want to mention two additional configurations that we typically use for our projects that help our development process to be even more integrated and automated at Silicon. First, with the help of AI tools, we can have a new artificial role that will do the code review process for us. So every time a developer opens a pull request, we can ask an agent to perform a code review of those changes. This certainly doesn't replace the human eye, but it will help to identify potential issues and bad practices right away. And the demo will be showing an example of this. And to name some examples, we could integrate this with the GPT API, for example, but also within AWS, we can use a Bedrock model and also ask it to review our code. And then we can also have the concept of infrastructure as code, where we define different resources explicitly by coding our infrastructure definition. And this is super helpful to control the changes that are made to our configuration, but also to easily replicate environments if we are planning to have maybe several of them. There are a few tools that can help us with this. We have Terraform and Pulumi as multi-cloud options. And within AWS, we have CloudFormation and also the CDK. Right? Okay, we are now ready to jump into a quick demo where I'll try to show you an example of some of the concepts and tools that we've been talking about. Okay, so let's jump in.
I will be sharing on the chat the GitHub address for this demo, so if you can follow along or you can review it later on.
Amazing, thank you. So as Marcelo said, we will be using this public repository for this very simple demo, trying to show how a change on this project gets all the way into the release and what things happen to get a better idea of the CI/CD principles and the actions that can happen. And this is just an example setup. We can have many tools integrated and many options. This is particularly focused on the AWS setup that we just discussed. So this is called User Service API. This is a very simple demo of a Node.js application for a user service API. It contains the implementation for a Lambda function designed to run inside a Docker container. And the CI/CD is built using CodePipeline, CodeBuild, and CodeDeploy services on AWS. So I have this project run locally. And if you can see, it is a very, very simple Lambda handler that creates a user's array and just returns that response, right? So this is the handler of that Lambda function. We also have a Docker file that let us build the image for this Lambda function. We have a few specs and assertions to validate our Lambda function. And we also have a Terraform definition for our infrastructure as code. If you're familiar with Terraform, you'll find this pretty straightforward. And if not, what we are basically doing is to define through certain syntax our infrastructure. So we define our ECR, our Lambda function, and the different components that make our CI/CD elements, right? So CodePipeline, CodeDeploy, CodeBuild, and so on. So the benefit of doing this is that we can have code control of this configuration, and we can also easily replicate environments to have easily spin up maybe a QA and an UAT environment with the configuration already built. We can pass in parameters to maybe define the details of our different components. So maybe we want our Lambda to have a larger memory for some environments and so on. We can do that with this type of configuration, right? So what I'm going to do now is to introduce a new feature, which is adding a new user. I already created a branch that is called fit add user. And what I'm going to do is to introduce a new user to the array, but I'm going to also add some mistakes on purpose to this change to see how our AI code reviewer captures those and help us to identify these type of issues, right? So I'm going to add a new user. Let's let compiler to this. I'm going to maybe add a comment over here. Return page. Let's add a typo over there. Maybe define a variable over here that is not defined or not used. Right, something like that. And then maybe some unreachable code. All right. So as you can see, I introduced a change, but also some mistakes. Let's try to push this change. Let's move now into our repo. This is our branch, and I will open a pull request. So by opening this pull request, what it should happen is that a GitHub action should pick this change, as you can see, and it will run a code review process that will ask an Amazon Bedrock model to review our change and provide us with feedback, right? So it's currently working on this. So let's wait a few seconds until it gives us that feedback. And this works because we have defined a GitHub workflow to use a particular Bedrock model. So this is using a standard foundation model of Anthropic Cloud, but we can use our custom model as well if we wanted to. And it's integrating GitHub with AWS roles. That's what allows this communication to happen. And we told it to run on every pull request that is open, right? Same way as if a developer will open this pull request. Yes.
So with this model, this AI, sending this information to AI, is there any danger that my code that could be confidential code is going to be seen by anyone else or could be leaked?
Right. If you need to follow some compliance rules, there's certain you need to be certainly careful with that. If, for example, using maybe an open API like ChatGPT's API, might not be ideal for that case where you need to be compromised to compliance. So the idea of using Bedrock is essentially that you keep control over that foundational model or the way you validate your code, right? So you can use your custom and already validated model. Maybe you can include guardrails as well on Bedrock that ensure that you follow the guidelines that compromise to your business, right? So yeah, certainly.
Right.
So from this feedback, as we can see, we got a review left by this bot that it found the mistakes that we introduced. So it's saying that we have a typo in the comment. It should be database instead of this. It's saying that there are a couple issues here. We introduced a duplicated ID, which is true, same as Alice, and that the email might not be in a valid format, which is true as well. So something else to review. There's a variable that is declared without using a const or let definition, and this doesn't affect the original result, so this is not clear what is here. And finally, there is a line of unreachable code that was added, and it should be removed as suggested. So great. For free, we got a nice code review. This is a simple example, but hopefully you get the idea that both the reviewer and the developer opening the PR can get a quick feedback of this code addition and new features, right? So anyways, I'm going to go ahead and merge these pull requests so we can see how this process moves forward. So now I'm going to jump into the AWS console, right? And we said that we will be using code pipeline for this. So I'm going to jump into the code pipeline service. And as you can see, there is a pipeline already running that is defined for our repository. And also something else that we can see on this dashboard is that we have in a single place some of the things we've been talking about. We have code deploy, code build, and a few other options. So we can control the whole ecosystem in this dashboard. So I'm going to go ahead and enter in this the code pipeline instance. And as you can see, what code pipeline offers is a set of stages or steps that we define, and we tell the rules that we want our code to pass in order to reach all the way into the deployment. Initially, we tell code pipeline to connect this source configuration into our GitHub repository. We can define our branch and our rules to trigger that execution. And what is happening now, it's a second step called build that is essentially building our Docker image, and it's going to push that image into ECR. So we have also that ECR defined that we just saw in the Terraform definition. So this is about this build step. We'll then have a test stage that will run our specs and validate that the new features are actually valid. That's what is happening right now. And finally, we have our deploy stage that uses code deploy and puts this new image version into Lambda. Finally, we have an API gateway update, which is sort of a post-deployed process that updates versions, right? So let's quickly check on this code build. So this code build, as you can see, it failed. So let's see why, and let's see the details of this process. As you can see, we have a lot of logs over here that shows what happened with that process. And it's saying that one of our specs failed. Let me zoom in that. And it's saying that we expected to have 3 users, but we are actually receiving 4, which is true. So we forgot to update our tests, and this was captured by our test validation process, right? So we need to go ahead and update these tests in order to pass successfully this build phase. So what else we have here? We can customize this build phase with maybe environment variables. We can define custom settings. We can also check the details that show, for instance, where what roles needs to be used by this instance. Maybe we need to connect this code build with other services. There's also a logs definition, an artifact definition, and also the build spec file that we mentioned that essentially is running our tests, right? So that's the goal that we gave to this build project, right? We can go back and have the historical set of events for this particular build. And we can navigate the historical events and logs to also be compliant with the history of things that happened. We can define different projects. As we saw, we have a project for the test file, for the test phase, for the build phase, and also for the post-deploy. So this is about a quick overview on code build. So as you see, our test failed. So let's go ahead and fix this test and click a new change. I'm going to just push this change directly to main. I'm going to just go ahead and update our test. from 3 to 4. Save some time, right? Okay, I fixed that the test in a new iteration. As a developer, I was able to see the logs, the reason why that failed, and fix that very quickly. So this, as you see, already kicked another iteration. It already picked up my change, and it's building again those changes. So it's going to build this, hopefully pass the test, and then reach the deployment phase. For this deployment phase, we can quickly see about code deploy, which was the other service we've been talking about. So code deploy presents a simple dashboard with some information about our deployment configuration. It shows the different steps that it does to complete our setup. But the important thing is the deployment configuration that we decided. In this case, we decided to have a Lambda Canary 10% 5 minutes type of configuration, which essentially will do this. The deployment will shift 10% of traffic from the current version to the replacement version at approximately 5 minutes after the deployment started, right? So we will be applying, thanks to code deploy, a canary release, and code deploy will show us that transition in this graphic. And during those 5 minutes, we can check if that new version makes sense. If for any reason that goes wrong, code deploy will be responsible for rolling that to the previous version so we can take a better look at those errors, right? So quick overview on code deploy. We have some other pre-built configurations that we can use. For EC2 or on premises, we have one at a time, half at a time, all at once, which is more about replacing servers. For Lambda deployments, we have other type of configurations, and we have a few more for ECS and Lambda over here, right? We can create our own definitions. We can change these rules to be maybe more percentage or more waiting time, so we can customize that as well. So this, again, quick overview on code deploy. So let's see where is our code deployment now. It seems it failed again. Okay, it's not liking that. So let me just go ahead and remove this. Any reason it's not passing. Anyways. I want this to pass successfully so we can see how that looks. As you can see, currently this service returns a few users. So the idea will be that this gets updated. While we wait for this to pass successfully, let me show you a quick overview on this diagram just to close the loop on this idea. So we started over here. This is the same diagram, by the way, that you can find on the repo. Over here. So we started as developers over here. We can control our Terraform and infrastructure changes also within the code. And we created a new feature branch where we open a pull request. This triggered an Amazon Bedrock AI review that went back and led some comments for us. We could have made changes on that. And once we approved those, this triggered a code pipeline build that started with a build phase that pushed our image into ECR. Then it went through a test build phase that it failed 2 times. So we needed to come back to our repo and start over. And the second time, or the third time, this should went through and start our deployment phase that will put the new version into AWS Lambda. This Lambda is controlled by an API gateway on the top of it, and we also have a custom URL for Route 53. A few other services that are being used are CloudWatch for our logs, AAM for controlling the role and accesses, and also S3. So overall, this is the idea of the demo, and as you can see, how those services interconnect and how we can quickly iterate the whole CI/CD process. Right? So this is more or less about the demo. I know, Marce, if we have any questions on the chat.
Yeah, a couple of questions. When you mentioned the infrastructure as code, so the question says like this: what are some best practices for managing infrastructure as code within CI/CD pipelines to ensure consistency across different environments?
Okay, so I would say good practices will be to have whether it's Terraform or CloudFormation or CDK, to have it as part of the code control to be committed. So developers can also check with each other the changes that happen to our infrastructure. If we decide to increase the size of a server, if we decide to add a new component, let everyone to be aware of that change and also make it part of your commits and historical changes for review. So same way as any other functionality of your system, I guess that's a good practice. And then if you plan to have multiple environments, it is important how you manage your different settings for maybe UAT, QA, production, as those might be different. So yeah, Terraform, for instance, has a workspace feature that works along with that idea. So yeah, that's also, I would say, a good practice in that sense.
Okay, we have another one. There's some people that is used to using GitHub Actions, and you didn't mention it. Is there any difference? Why choosing one option over the other?
Yeah, in this demo, for instance, we use both. We use GitHub Actions to trigger that change when opening a pull request and calling an Amazon Bedrock endpoint to get feedback on that. And yeah, that was exactly the idea, to show that both things can be used together. I could have created all of these within GitHub Actions. I could also have a mixed option where I create using GitHub Actions the definition of our steps, but running in code build custom GitHub runners, which is possible as well, right? So that integration between GitHub and AWS works pretty good. But what I like about using code build and code pipeline is that you keep most of the things within your AWS ecosystem. Again, if you think compliance and having everything under control and with good set of permissions, having the AWS option will be also a good benefit in that sense. Yeah.
Okay, that's great. Thank you. All right. Thanks for joining us. And thank you, Will. We hope everyone watching found this session helpful. So if you need to or want to improve your DevOps or you have a specific case that you would like to discuss, feel free to reach us for a free consultation. I shared in the chat a Calendly link where you can you can set your time and reach us any time you like. So we will love to help, and looking forward to hearing from you. See you next time. Bye.